That's good. I'm not going to fiddle around with it. Let's get into Advent of Code 2023, day 16. The floor will be lava. Okay. With the beam of light completely focused somewhere, the reindeer leads you deeper still onto a lava production facility. At some point, you realize that the steel facility walls have been replaced with cave, and the doorways are just cave, and the floor is cave, and you're pretty sure this is actually just a giant cave. Finally, as you approach what must be the heart of the mountain, you see a bright light in the cavern up ahead. There you discover that the beam of light you so carefully focused is emerging from the cavern wall closest to the facility and pouring all of its energy onto a contraption on the opposite side. Upon closer inspection, the contraption appears to be a flat two-dimensional square grid containing empty space, mirrors, and splitters. Ah, thank you. I keep forgetting that. See, I'm a professional streamer. Yeah, that's what I was thinking, Robin, when I saw Mohad say scene. All right, the contraption is aligned so that most of the beam bounces around the grid, but each tile on the grid converts some of the beam's light into heat to melt the rock in the cavern. You note the layout of the contraption, your puzzle input, for example, this. Actually, what I'm going to do is I'm going to cheat. I'm going to go here so I can do a screen cap and then narrate over that. And then I'll go here. Right. The beam enters in the top left corner from the left, heading to the right, and its behavior depends on what it encounters as it moves. If the beam encounters empty space, it continues in the same direction. Right? If the beam encounters a mirror, the beam is reflected 90 degrees depending on the angle of the mirror. Okay, that makes sense. If the beam encounters the pointy end of a splitter, the beam passes through the splitter as if the splitter were empty space. Okay. If the beam encounters the flat side of a splitter, the beam is split into two beams going each of the two directions. Okay, I think I understand. Beams do not interact with other beams. A tile can have many beams passing through it at the same time. A tile is energized if that tile has at least one beam pass through it, reflect in it, or split in it. Okay. So we have a little reflectory thing here. Beams are only shown on empty tiles. Arrows indicate the direction of the beams. If the tile contains a beam moving in multiple directions, the number of distinct directions is shown instead. Okay, so here we have two different directions. Here we have two different directions. But all we care about is whether or not the beam reached that tile. So in the example, we have 46 beams energized. And the answer is how many tiles end up being energized in my puzzle input. Let's find out. Get input. 2023, day 16. 110 lines. And it looks like 110 columns too. Because my window is, I think, 110. Or 100 rather. Okay. So it looks like we're going to go here and then split our way down and then okay. I think I get it. Let me just pull it up here so I can see it without wrapping. Yeah. So we start, it said start to the right. Oh wow, it zoomed in this side too. That's all right. Where did it say? Right, with the beam starting in the top left, heading right. Yeah. Okay. Stop left, heading right. So we're going to come down here, pass through this, and then get split off that way and off that way. And then it gets split again and so on. Okay. All right. I think I know what I need to do. Once again, we're going to make a grid. At some point, I'm going to actually write some grid code. Today's not that day. Wizard says I copied the grid from day 10. Oh, yeah, that's smart. Smap says hi. Hi, Smap. How you doing? How did Captain Goder get on today? Was it a good one for him? I still have to do 16 first, though, so use of undeclared type. All right. 23, 16. There we go. All right, so parsing should be easy. Do we want to do like I did last time and keep track of the empty spaces, or yeah, why not? And then do we want to stick it in a vec of vex, or do we want to stick it in a hash map? I think I did hash map last time. Let me take a look at my day 10. Yeah, I stuck it in a hash map. All right, let's do a vec of vex this time. Oh, this is a contraption. Of tiles. All right, there we go. Nox, hello. Oh, Smab only just got back in today. Okay. No worries. Let lines equals AOC lib. Read lines. Input day 16.text. And if we do a vec of x, all we need to do is say for line in lines, and then we're going to create a row, and then we'll say for ch in line chars match ch. All right, so we have this character, which is going to be, let's, I said tile. I should call it a mirror, right? Enum mirror. And we have, I don't know, what do you want to call it? I guess a slash mirror, a backslash mirror. And then we have a horizontal splitter and a vertical splitter. And then we have empty space. All right, then here we just need to translate it into each one of these things. Actually, we can do this. Like that. Change it from slash to this is mirror colon like that. And now this needs a backslash. Horizontal splitter is that, vertical splitter is that, empty space is that. And this will just be row.push. And this will be panic. And we'll close that, semicolon that. Oh, no, I have to close that first. Then close, and then close this. And close that. And then after we're done here, we say self contraption push row. So that should give us the whole thing, except I have this extra line here. There. Uh-oh, it couldn't read the file? Didn't I do a get input? Oh, 2316. I said day 16. Oops. There we go. We can try printing out the first row just to make sure. Self row, contraption 0. Oh. All right. So how does it look? Backslash mirror, horizontal splitter, a bunch of empty space, and a forward slash. Where's the forward slash? I guess I call it just slash mirror. Okay. I think it's working. Now we just need to trace a beam. I don't think this is going to be too difficult. We can have a row and a column, and just depending on what we hit. And because we can split in two, we're going to just have a queue to work on. And a queue doesn't matter. It doesn't have to be a a queue. It could just be a stack of stuff to work on. So let's just call it that. Mut stack is equal to vec new. And we're going to start on this guy. Stack.push. I guess we could just do this, right? Vec bang. The location is going to be 0, 0. And the direction is going to be to the right. What does that mean? Let's define that. we're going to do, let's try to pick a consistent order, right? So we can say up, down, left, right. So up is going to be this, down is going to be this, left will be this, and right will be 1, like that. Up, down, left, right. So this is going to be, and then I guess what we do is index into here, into the DIRS array. So we're going to be traveling right, so that means a 3. But we want to have single things in here, so a tuple like that. Good one, hello. All right, so just some warnings that we're not using stuff. That's fine. Let's get rid of this print. And now that's our stack. So we can say while let some position and dir in stack pop, right? And now we're going to translate this, and we're going to just say, okay, what's here? What direction are we going, and how do we translate that to the next location? So we're going to say match self contraption of pos.0, pos.1. And it's going to be all of these guys. If it's a slash mirror, oh yeah, so we have to figure out which direction we're going and how to rotate. So for the slash mirror, and rotate to the next location. And then backslash is just going to be the opposite of that. Now, I don't think there's anything difficult here. It's just fiddly getting it right. If we're going, let's see, if we're going up, it's up, down, left, right. So we have to map D to a new D. That new dir is equal to match D dir, right? If we were going up and we had a / mirror, now we're going to go to the right. If we're going down and we hit a / mirror, now we're going to go to the left. If we're going left, now we're going to go down. And if we're going right, we must be going up, right? So now we're going to push that onto our work queue. Oh, we have to add our new location. Oh, and also we also have to make sure we're not going off the map. Unfortunately, I think I'm using usizes for everything. Because I'm indexing into here. Let me try changing these to isizes, and then I'll just use usizes. I'll use a cast here. There. So now I can say if pos0 plus dirs of new dir of 0, oh, this is sloppy, is less than 0, or positive 0 plus dirs of new dir plus 1 is greater than or equal to self contraption len. Wow, okay, this is bad. I'm not liking this anymore. Width, height. Self width is equal to self contraption len, oh no, 0 len as size height. So now I can at least say that here, but this is still awkward. Oh, what I can do here is just say new pos is equal to pos0 plus dirs new dir of 0, comma, pos1 plus dirs of new dir dot 1. Right, and now I can just say new pos 0 less than 0, or new pos 0 plus 1 is greater than or equal to width, height, or new pos 1 is less than 0, or new pos 1 plus 1 equal self. I guess we don't need to add 1, right? Because if we're comparing greater than or equal to, then we've already moved to the right location, width. All right, so if we're off the map, then we can say continue. Otherwise, this is our new working location. So we say stack push, new pos, new dir. Right? And then we have to do exactly the same. Let me just hit run on this just to see how far we get. Underscore not covered. Yes, that's true. All right, and so we hit a to do. It doesn't say which to do. Oh, 67. So we hit a backslash mirror. That's the first one, right? So no, fair enough. Whereas it says unreachable. Yeah, I could do that, but does unreachable let you put text in there or no? I guess it does. Okay, the backslash mirror is exactly the same, except opposite. The only difference is the new dir. Everything else is exactly the same. So I probably want to factor this out. Can I do it that way? If I say let new dir equals, and then factor all of this out here, and just do it once down here. Right? Oh, no, I can't, because the horizontal split and vertical split are going to require 2 of them. Okay, let's put that all back. This is a little bit annoying to do it this way, because there should be a better way to calculate the next direction based on whether you're going rotating to the left or rotating to the right. Why don't I do that? So we can see this is 0, 1, 2, 3. This backslash mirror, if we're going up on a backslash, this is a backslash here. If we're going up, then we're going to go left. So that's going to change to 2, right? If we're going down on a backslash mirror, then we're going to go right, which is 3. If we're going left on a backslash, then we'll end up going up. And we're right, then we must be doing this. So we can do this here. If I do it rotatingly, right? If I change this instead of up, down, left, right, let's make it up, right, down, left. And then maybe it'll be easier to rotate things. So right becomes this, 0, 1. And maybe it'll be simpler. Let's map it out. This group says +2 mod 4. Yeah. Right, this is +2 mod 4, but this is not. This is different. This is -1 mod 4. Nope, not even that. Okay. Yeah, if I do the rotation thing, I think it'll make more sense. So if we're going up on a /, then we're going to go right. So 0 goes to 1. If we're going right, then we're going to go up. Oh, really? Okay, so we're not, this isn't helping. If we're going down, then we go left. And if we're going left, then we go down. I don't see any easy way to do that. So did that mess up the backslash? Let's check out the backslash. If we're going up, we go left. Oh, 3. What am I doing? This should be 2 and 3. And 2 and 3. like that. It says 3 minus dir. Yeah, if I do it that way. Okay, here's what we're going to do. Okay. So this is, if I do 3 minus dir, 3 minus 1, 3 minus 2 is 1, 3 minus 3 is 0. Okay, so that works. So let's do that. And that way I don't have to have this unreachable thing. And we have that. We're still going to have all of this, which is going to be annoying, but I'll figure out how to refactor that. And then this just is dir, like Scoop said, dir plus 2 mod 4. So now if we hit a horizontal splitter, it depends on which direction we're going. If dir is equal to up or down, right? Then we're going to split it into 2, assuming that it fits. So maybe what I do is I pull this out as a new function. Which just returns do we need self? Yeah, we do. And then pause isize, and dir isize, and it returns a new pause option, new pause isize, right? And then we can do this, and we can say none else new pause. And then like that. Right? And then down here we could just say if, actually I can put this up there too, right? Let's do that. That way this is all self-contained. Right? Oh, I have this as an I32. I guess it should be usize because we're indexing into that array. And then this changes here, dir. This changes to here, dir. And then we just say that's the new dir, and then we can say if let sum new pause is equal to self next pause of position and new dir. Then we're going to stack push it. Right? That's pretty clean. Wizard says struct pause isize. Yeah, you know, if I were being fancy, I suppose that's worth doing. I'll give you that one, Wizard. Struct pause isize. Oh, and then yeah, pause. I guess it's copied. We could just copy it in. Oh, pause is usize. Dir is usize. There we go. And then it's option of a pause. And then up here, I'm going to have to create it as a pause. Now I don't have to specify isize then. Right? How's this looking? Terrible. Oh, I have to make it as a pause. There. That wasn't too bad. Scoop says fancy is using macro rules. Yeah, if I were going to get really fancy, I write this whole thing as a proc macro, right? Right. Okay. So /mirror / mirror done. Scoop says, no, God, no. Rezvan, thank you for the follow. Welcome. All right. What's next? So yeah, for the horizontal splitter now, we're going to split it to the left and to the right. And I know which way is left and which way is right because I've forgotten them. Okay, left and right are 2 and 3. So we can say if let sum new pos is equal to self next pos, current pos 2, then we're going to stack push. And then do the same thing for 3. For dir in 2 dot dot equals 3. Right? And then the vertical splitter is exactly the same except completely different. Right? Like this. That gets that one, and then we change this 0 to a 2 and this to a 3, and this becomes 0 and 1. Empty space. All right, so the only thing, oops, is nothing for now. The only thing missing is the thing that is going to get us our answer. Oh, yes, this is true. I guess I was just being too fancy. It doesn't hurt to clone it. Let's find out together if tuple structs automatically implement clone or you have to add it. There you go. There's the answer. Wizard says, yeah, got to do it. I'll do all 3. Might need partial equal and equal or something like that because I'm going to be throwing these in hash set in order to keep track of which places we visited. All right. Yeah, that's all we need to do now is create this hash, visited, let's call it, new. And then every time we pop something off the stack, oh, we might have to implement hash for this. Okay, but that shouldn't be bad, right? It should be derivable. All right, let's find out. Yes. Oh, I was looking at the wrong error. EQ. Wizard says named tuples have to use derive. Okay. All right. Let's see if we have an actual answer here. Visited len. Oh, yeah. This says 2. So that's probably not accurate. Oh, right. We have to treat horizontal splitters and vertical splitters as though they're empty space. So we need to do an empty space is missing out its code as well. So it's just continuing if let sum new pos is equal to self next pos. Pos dir stack push new pos dir. Let's put that code here and put that code here. Nope, nope, wrong one. Here. Right. Computing. Uh-oh. Uh-oh. Oh dear. Okay. So we clearly have an infinite loop. And I'm imagining that something's just bouncing around in circles right now. So it's never going to finish. What's a good way to do this? I can't just say if it's already been visited, then ignore it because it could be going in a different direction. Right? In each one of the directions it can be visited. All right. Yeah, Misery, that I can't do that because different beams will be going in different directions, and we can't just stop if another beam hit it. And right, that's the next option, Wizard, right? Except then the count is wrong because we don't want to count the same position multiple times. Although I could just iterate over that and recollect it into a new hash set. Scoop sets the problems with the splitter. If you use a splitter, change it to an empty space, or change it to something completely else so you hit it again, you don't process it. Let's save that in the back corner. But let's do this. And then what I can do is I can iterate over the visited list and create a new hash set out of that. Energized, right? Because that's what it was calling. Equals visited iter map position and direction to just position, and then collect into a hash set. That's a hash set of references to positions. Is that even going to work? I guess so. And then we can say energized len. There. It finishes. SMAP says loops do exist. Let's see if this is sufficient. Yay! Okay. It's a little inefficient because I'm looping over everything. And then I have to loop over all of the things we visited, and then we grab all the positions from that, right? And then make a new hash set out of that to eliminate the duplicates, and then we get the length of that. So it's a little sloppy, but it works. Smab gives me a star. Thank you, Smab. Goodmonk says, yay. All right. Oh, and Mana Kanapa, thank you for the follow. I was too absorbed in my my coding to have noticed. I apologize. Git status. Git add source git commit -m 2023 day 16 part 1. All right, that wasn't too bad. Let's see what part 2 says. Part 2 says, as you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There, a collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of the two directions for the beam if it starts on a corner. For instance, if the beam starts in the bottom right corner, it can start heading either left or upward. All right, so we just have to do this for every starting direction. So the beam can start any tile in the top row heading downward, any tile in the bottom row heading upward, and so on. Okay. To produce lava, you need to find the configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting the beam in the fourth tile from the left in the top row. Okay. What are the chances, you think, that starting in the upper left, and heading right actually is the answer? I'm just going to throw it in there because I'm brave. Nah, of course not. Okay. So, how do we want to do this? 16. 17 take because today's the 17th. Knox says they probably check for that. Yeah, they probably deliberately chose inputs that don't allow you to do that for Okay, so I guess we just work our way along the top. So first of all, we're going to extract this code, right? And then we're going to refactor this into its own function. Right? delete. And then we'll just pass in the direction and starting point that we want to do. So fn count energized from self. The starting position, which is going to be a pause, and a starting direction, which is going to be. Can we infer? Oh no, we can't infer that from the position. If it were a position up here, we could, but if it's one of the corners and we don't know which way, so we actually have to specify a direction. And this is going to return count of how many tiles got energized. Right? So this becomes this, and no semicolon. Right? And then we have to have our starting position. Let mut stack equals vec bang pause and dir. I think that's it. Let's rewrite or put the code back into part 1 so we can actually get an answer. It's just going to be self count energized from position 0, 0 and starting at 3. Oh, collect into a hash set and then len. Cargo, oh no, bacon. Run. 7562, is that right? That sounds right. That's right. Okay. So that's all we had to do there. And now we just, for part 2, we just need to run all the directions. So we can say for, we can do the row, top and bottom row first. Call in 0 dot dot self width. Right? Self width is an I size. Yeah. Let max is equal to 0. Mut max is equal to 0. Max is equal to max dot max of self count energize. Count energized. Position of, and it's row column looking down. And I've forgotten which way is down. 1. 1 is down. Right? And then we can do the same thing looking up. Starting instead of a position at row 0, we're going to start at height -1, at column going up, which is that. Right? And then we can do the same thing for the rows. For row in 0 dot dot self height. And that becomes row 0 and row width -1. And the direction for this, starting at column 0, we're going to go to the right, which is 3. And this to the left, which is 2. And then we just output the max. Oh, self. Right. Computing, 7793. Yay, that's the right answer. Okay. Oh, that's neat. Look at that.